Hello, good morning. You're all to MAMU with Jarvis, and as usual, we are into mathematics for grade 10. Today, we'll focus on algebra. We've started an aspect of algebra. Some writers might choose not to classify it as algebra, but because of the kind of work I want to do, I have classed this topic as algebra. Our textbook of reference is the Essential Mathematics for SS1. I love this book. I love becoming a lover of essential mathematics because it's quite into the teach yourself model, which I so hold strongly. And then it also affords me, the teacher, to see different examples and problems and be able to upgrade myself. At the time of making this video, the WAEC SSC result is out, and I know a lot of my students are already checking to see what the result was like. And so far, the feedbacks I've gotten have been very good. At least from the 3 students I prepared for the WAEC, they all passed their mathematics. Those I had to prepare for physics, chemistry, further maths. Funny enough, the ones I helped in further maths took the exam and ended up coming up with an A1. Have these. Well, it's such a nice profession to be in, and I'm trusting that as I keep upgrading and trying to help you to get better at your studies, we begin to have turnout students who will not just be exceptional going to the exam, but to be exceptional when it comes to life, testing their IQ. For today, we'll be looking at indices. So we start off the class right away. All right, so we're looking at indices. Indices is a plural form of the word index. Index. So what essentially do we mean by indices or index as it pertains to maths? Let's go back a little to semantics. When you use the word index, you could mean power. You could mean superscript. Let's sound a little more controversial. You could mean log reading. Some students are already asking, log reading? Yes. What's the definition of log reading? The logarithm of a number is the power. No more than that, because here in MAMU, Mathematics Multiverse, we're going to shred and throw the mathematics universe into chaos. But the chaos will be such that will help you go into it and be like, wow, this is really what it is. Now, so back to my discussion. Indices, index means power, superscripts, and what? Logarithm. But major spoken, it will make virtual appeal to some students. So let's appeal to those students who are virtually inclined. Now, when I write a number, say 2, and I write a superscript, say 4, it means that this number is raised to what? 4. So this is the part that is called the index. This is the part that is called the log, short. This is the part that is called the power. Are we seeing that? And this is the part that is called the superscript. This number is what we call the base, or the reference number. So, having said that, let's now try to define what is an index. An index will simply mean the number of times a number is multiplied. That's the key word here. Index, number of times a number, reference base is being multiplied. So that's what an index is. It talks about the number of times a number is being multiplied. That's what an elementary is, but it gives you an idea of how to play with this. So if I say 2 to the power of 4, what this means is that 2 is multiplied what? 4 times. So 2 times is 4. 4 times 2 is 8. 8 times 2 is what? 16. So this will give us what? 16. So this means that 2 raised to the power of 4 will be equal to 16. The power 4 talks about how many times 2 is being multiplied, giving you the number 16. Much later, when we go into some more work in maths, you'll discover that this number is called the antilog. Oh, students are already like, oh, what are you up to? Don't worry. Take our time to digest this and no distant time you get to enjoy it. So what have I said in all? The word index, as it applies to mathematicians, refers to the number of times a reference base or a number is being multiplied. We'll start with that, and as we go on the class, we'll build on these assumptions. Okay, we've tried to introduce the matter of indices. Now, in your JSS2, what we call your grades, we introduced indices to you just after standard form. And we carried out some exercises that will make you decide what to do when you see some problem with the indices. Now, we have what is called laws of indices. My approach to this topic will not be to tell you this is law 1, law 2, law 3. No. My approach will be to show you problems and then tell you what to do when you see particular problems. All right. Now, the laws of indices exist to help you with a shortcut to solving problems in indices. That's one. But please take note of this when you're solving in indices. The laws of indices work with the understanding that, one, you have a strong knowledge of your prime numbers, because that's the approach I'm going to take to this topic. The concept of prime numbers and primes. Two, that when you consider indices, you know the right laws to use per time. So let's start off with it and see how it goes. Now, for instance, the first I will consider will be if I have 2 raised to the power of 3 times 2 raised to the power of 4. We know that 2 raised to the power of 3 will be 2 times 2 times 2, 2 multiplied by 3 times. And we know that 2 raised to the power of 4 will be 2 multiplied how many times? 4 times. Is that not? All multiplied together. So let's count. How many 2's have I used so far? 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, and what? 7. So I've made use of what? 7 2's. I've made use of what? 7 2's. So it means that if I say 2 raised to the power 3 times 2 raised to the power 4, what I'm going to get will be what? 2 raised to the power 4, 7. How did I get this? It will only mean that, now let's look up. 3 plus 4 will give me what? 7. Is that not? So which means that 2 raised to the power of 3 times 2 raised to the power of 4 will be what? 2, 3 plus what? 4. The countings you are doing here are actually talking about the index or the indices. Because remember we have said that the index talks about the number of times a particular number is being what? Multiplied. If 2 is multiplied 3 times here, and 2 is multiplied 4 times here, how many times are they being multiplied? How do I get that? I will do what? I will add them. So it was based on this. We now have a law that says if I have x to the power of a times x to the power of b, it will be same as saying x to the power of a plus b. Take note of this. The law of indices works most effectively, at least at this stage, when the base or their bases are the same. Don't forget that the base have to be the same for this law to work. So this is the first law. we have, and some books we call it the law of what? Addition of indices, or the law of what? Multiplication of what? Numbers. Now, number 2. Let's take another scenario. But this is where I'm going to approach the problem. Taking different scenarios. Now, let's take a scenario we have 3 raised to the power of 4 times 3 raised to the power of 1. How do we handle this? Let's use division. Let's use division. We're going to have a lot of practice problems. So let's take the laws out and see how many we can cover. There are so many. There's so many laws. So many laws we need to do in indices. Now, this is division. Now, this one means 2, 3 times 3 times 3 times 3, 4 of it, divided by what? 3. Remember that when you're writing your division, you will see what? 3 times 3 times 3 times 3, divided by what? 3. This will cancel this. Now I'm left with what? 3 times 3 times 3. How did I get this? You will notice that while I was dividing the numbers, the 3 was reduced by 3 to the power of 1. So it means that every time I'm dividing, I am reducing this one. I see it. This one will begin to reduce this one. So what can I conclude? I can conclude and say that 3 to the power of 4 divided by what? 3 to the power of 1 can be written as 3 to the power of 4 over 3 to the power of 1, which will be saying 3 multiplied 4 times, and I remove 1 because I'm dividing by 3. And my answer becomes 3 to the power of 3. Notice that at this stage, our focus is not on getting the answer. Oh, 3 is the power of 3 is 27, or you multiply out. But that's not the focus of this topic. The focus of MAMU in this topic is to take it to the realm. It's a realm. It's a realm. They call it one of the small, a very small realm. We call it the realm of indices. So that's our focus in this topic. That's what we're going to be working. So I can say, based on all of our work, that I'm going to the second rule that says that what? X raised to the power of e divided by x raised to the power of b is what? X raised to the power of a over b. X raised to the power of b, which will be x raised to the power of a minus b. X raised to the power of what? A minus b. Let's allow that to digest. All right, so we go to the third law, which I will call C. Now, we call this law the law of zero index. And it's usually very interesting how to explain this one. Now, the law of zero index says that what do you do when you have a number raised to the power of 0? What would it be equal to? Now, to explain this, what the answer will be, I'm going to use another analogy. Now, look at this. We know that from elementary maths that the only way I can get 0 is by subtracting two numbers that are the same. Is that not? 2 minus 2 will give you what? 0. So let's imagine that I have 3 raised to the power of 2 minus divided by what? 3 raised to the power of 2. What would it be equal to? Now remember that, let's get this understanding right. 3, we have established from previous law that if we divide bases, you are subtracting their index or their indices. That's what it means. So imagine two numbers that are the same, having the same index or indices. What happens? What would the answer be? Now, watch carefully. So it means that, now look at from this side, it means that 3 raised to the power of 2 over 3 raised to the power of 2 is the same thing as what? 3 raised to the power of 2 minus whatever, 3 raised to the power of 2 minus what? 2. Because we have said that division means, so this could either mean this, or it could mean this. It's either it means this one, or it will mean this one. So what it means is that these two numbers are the same, so I can cancel them, and I'll get 1. Equal to, this will be 3 raised to the power of what? 0. I see this. So it means that if x is used, I want to make a general statement. It means that x raised to the power of 0 must be equal to 1. So this becomes equal to 1. And that's how we say that the index, that if by the concept of 0 index, a number raised to the power of 0 is equal to what? 1. We look at it from two perspectives, two schools of thought. We try to equate two schools of thought. Sometimes later you equate what is called equations. We're trying to bring two schools of thought together. One school of thought says, if I have two numbers with the same indices, what do? I divide them like this. Another school of thought says, no, why not work at the level of indices? And he got this one got this one. From the same line of thinking, it only means that by disagreeing on which road to go, you were able to solve a problem such that anytime the number is raised to the power of 0, the answer is what? 1. And that is how this law came about. So that's the next law we have considered. The next law we'll treat is what we call the law of negative index. The law of what? Negative index. So let's look at it. Negative index. I sometimes call that law the law of reciprocal. That's what I call. So it's a build-up from concept of reciprocal. It's a build-up from the concept of reciprocal. All right. How does this law work? How does this law work? Now, I have a number. Okay, let's use x that is raised to, let's say, negative. The concept of negative integer or negative index is that the index or the indices is treated as what? Negative. So that's the power of A, for instance. What will it be? Now, I can take a shortcut to help you understand this concept. Remember, from reciprocal, we know that x raised to the power of minus 1 is equal to 1 over x. Is that not? X raised to the power of minus 1 equal to 1 over what? X. That's what we know from reciprocal. So, by implication, if I have x raised to the power of negative a, it will simply be equal to 1 over what? X raised to the power of a. This is what we call the concept of writing a negative index in what? In its positive index form. So, 1x raised to the power of negative a would mean what? X raised to the power of 1 over x raised to the power of a. Now, some people might find it very difficult to pick this thing out. Remember, we have said that when you multiply numbers, what are you doing to their indices? You are what? When you multiply numbers, you are adding their indices. But when you divide numbers, what are you doing? You are what? Subtracting their indices. So let's look at this for instance. It means that x raised to the power of 1 over x raised to the power of minus a would mean 1 divided by x raised to the power of a. That's what it means. X raised to the power of negative a will mean 1. Because we know that 1 multiply anything will give me what? 1 multiply anything will give me that thing. Is that not? So it will mean that 1 divided. Because we have said that anytime you have negative, it means that you are doing what? You are actually dividing the number. So it means take a number that won't affect it, divide it by x to the power of a. What do you have? It will be what? 1 over x to the power of a. So I don't know what paradigm, what direction you're coming in from, but I trust that whatever the direction you're coming from, this would help you to understand the concept much better. Okay? All right, we're now on to problem solving. And we have question 1 that says simplify, leaving the answer in index form. Simplify, leaving your answer in index form. Right. Remember that we said that the topic seeks to address what happens at those of us who watch a lot of movies, particularly those ones that revolve around the MCU. At the Ant-Man is my favorite. What is happening in that realm where things seem to be very, very small? Quantum realm. What's happening at the quantum realm? That's what we're trying to do here. So we are expected to leave our answers in what? Index form. All right, so let's start. Number 1, A is 2 raised to the power of 2 times 2 raised to the power of 4. Remember that you are multiplying. So what's happening to me? You are multiplying the bases at this stage, so you add up their indices. So please, let's not be in a hurry to solve and get an answer. Let's be careful to take note of specific things. The basis must be the same. You are multiplying, so you do what you add. Next one, 5 to the power of 6 times 5 to the power of 2. The bases are the same. You are multiplying, so you add up their indices. Question C, 10 raised to the power of 5 times 10 raised to the power of 7 times 10. Now, this is the place I'm going to make a little observation. If I write 10, 10 is 10 to the power of 1, which means 10 is multiplied once. 10 is what multiplied once. So that will be to the power of 1. And that will give me what? 10 to the power of 5 plus 7 plus 1. And that will be 10 to the power of what? 13. Let's look at D. X to the power of 7 times x. Same thing is applicable. This x here will be to the power of what? 1. Bases are the same. You're multiplying, so the indices will be added. X to the power of 7 plus 1. That will be x to the power of what? 8. Question E. What do you have in E? A to the power of 3 times a to the power of 2 times a. Now this a will mean a to the power of 1. And that will be what? A to the power of 3 plus 2 plus 1. That will give you what? A to the power of what? 6. Let's go to F. In F, you have 5 to the power of 2, a to the power of 1. Remember, when you just write a, this a to the power of 1 times 5 to the power of 4, a to the power of what? 3. Now, remember we said that to apply the laws of indices, their bases are the same. Now, in this setup, we have a question where two terms are given to us, and we're required to try to separate the terms as it were. So what do we do? This is also going to imply 5 to the power of 2 times a to the power of 1 times 5 to the power of 4 times a to the power of what? 3. I see that because this 5 to the power of 2, a to the power of 1 means I can break it like this. So what do? I collect my terms. This is multiplying this, and this is multiplying this. Now, because we're just starting the topic, I will take pains to develop my approach these days. I try to enable students to deal with randomness. But hence, we're just starting. I will then take the trouble of writing out this way. So, what do you have? That's what we're going to have. And this will now be equal to what? 5 to the power of 2 plus 4 and A to the power of 1 plus 3. What would that give you? That will give you 5 to the power of 6 and A to the power of what? 4. Right? Okay, so I've done F. Let's go to G. Now in question G, you are told A to the power of 8 divided by A to the power of 4. What does this give you? This would mean A to the power of 8 over A to the power of 4, which will be what? Subtraction. The bases are the same, so you do what? You subtract because you are dividing. That will be A to the power of 8 minus 4. And that will give you what? A to the power of what? 4. Right? So that's for G. What about H? In question H, you are told 6x to the power of 6 divided by x to the power of 3. How do you handle that? How do you handle that? This will mean 6x to the power of 6 divided by x to the power of 3. Yeah, please, you really need to watch me when I'm solving. You really need to watch while I'm solving. Okay, so this will mean what? 6x raised to the power of 6. Now you are dividing this minus 3. And that will give you what? 6x raised to the power of 3. Now what about I? In question I, you have b to the power of 3 times b to the power of 4 times b. Remember that when we say b to the power of 5 divided by b to the power of 6 times b, that will be b to the power of 1. So how do you anchor this? This will now be equal to what? B to the power of what? 3 plus 4 plus 5 over b to the power of what? 6 plus 1. Take it gradually. When you're solving questions like this, generally when you start a new topic, take the concepts gradually. Don't be in a hurry. Take the ideas one step at a time. This will give me b to the power of 3 plus 4, 7 plus 5, that's 12, over b to the power of 7. I'm just using this approach. If I had to be in an exam setting, I wouldn't use this because I've already discovered the faster way to solve this. And that will be equal to b to the power of 12 minus 7. And that will give me b to the power of 5. So b to the power of 5 will be my final answer. Let's finish question 1, right? So we go to question 1J now. We continue from J. That says 8a cubed divided by 2a to the power of 2. What would this be? This would mean, now look at this carefully. If you look at this, this would mean 8 times 8 to the power of 3 over 2 times 8 to the power of 2. This can go here 1, this can go here 4. So that will be what? 4 a to the power of 3 minus 2. So this will give you 4a to the power of 1, which will be what? 4a. Remember, we have said that a would mean a to the power of 1 also means what? A. Right? So let's go to J. Then we have done J. Let's go to K. K, 5 to the power of x minus 1 times 5 to the power of 1 minus x. What would this give you? This will be 5 raised to the power of x minus 1 plus 1 minus what? X. When writing this, put them in bracket first. Then by the next line, you put them up. X minus x is 0. Minus 1 plus 1 is 0. So that will be 5 raised to the power of 0, which we know to be equal to what? 1. So that will be the answer to K. So we have one more question to go, and that is L. Now in question L, we are told that 5y to the power of 4 times 3y to the power of 5 times y. So how do you handle this? 5 is a number, 3 is a number. So you multiply the numbers. 5 times 3, that will equal 50. Y. You're multiplying. So that will be the power of 4 plus 5. Now look at this y. Look at this y. This y means to the power of what? 1. So what does that give you? That will give you 15 y to the power of 4 plus 1. 4 plus 1, 6 plus 4 plus 1 is 5 plus 5, and that will be what? 10. And that will be the answer to that question. Okay, that will be the size of our part for this class today. I would expect you to go back and try your hands on the other exercise and gain mastery of them. As usual, MAMU will return with more exciting classes, and we trust that you will gain better from our next class. Thank you very much.